Hello everyone, I hope all of you are doing fine. In this series of videos, we are going to see how to create these parts in SolidWorks and then assemble them as shown in this figure. After assembling them, we will be creating drawings of the assemblies, exploded view, generating bill of materials, and also creating detailed drawings of all of the parts. This video series is actually a request of my students who have just completed their SolidWorks course in Drawing Institute. This video will help many of you who are watching this channel to create basic parts into SolidWorks and assemble them, and also manage the information associated with all of those parts to generate a proper bill of material. This will be the bottom up method. That means I will be creating the parts first, then we'll be assembling them into the assembly module. So without further ado, let's start modeling in SolidWorks. Right now what we are seeing over here is a figure of master rod in our assembly. All of the other articulated rods or the connecting rods will be attached to this master rod at these regions. Okay, and modeling this part is pretty simple. As you can see, this part looks very complex and very big. Well, it is not that complex. We'll go step by step and see how this solution becomes easier. Basically, creating or modeling any part is not that straightforward. Most of the times we have to consider lots of factors and uh, criteria upon which we decide how we are going to model these parts. So what all references we'll be keeping, and which all the dimensions will be significant and which all will be dependent, and according to that we create the part. In this case I am trying to create the part in such a way that all of these dimensions given over here would be easy to handle at any stage, and we would be able to modify if there is any change in the design, then modify these dimensions with less bottlenecks. So without further ado, let's start modeling this part. As you can see that it's quite tricky to decide from where to start, so let's start from these rings, okay, which will be extruding at a height of 70 and here at a height of 42. And these are the dimensions 63, 52, 35 and 24, and this is the distance from center to center between them. So we will go onto the top plane because these rings are lying on the top plane. If you see the isometric view, you can see that this is the top view and this is the cut section AA of that view. Okay. So let's select the top plane, go to sketch and create those circles. 63, 52, 35, 24, select these two centers as well as the origin, holding control button and make them horizontal. Distance between these two centers, you can select the centers or you can select the circumference. It will measure from the centers. It's 250 units. Now if you see at the image, the distance between this edge from where the shape starts changing, okay, from here up to the center of this circle or ring is 133. So I would consider this will be a different cross section, this would be a different cross section and it will change at right plane. This is what I'm thinking, this is what we are planning. So instead of going and creating a separate plane, we'll try to utilize the right plane of our modeling environment to get those two different cross sections. Great, so our sketch is fully constrained. It's very important that we fully constrain our sketch and then use them into the operations. Extrude, I will select this ring, and of course I don't want to extrude this outer cylinder. I want to select this contour. Okay, so select the appropriate from here, about mid plane by an height of 70. So the sketch gets hidden. Want you can just select it from here, you can unhide it and select it from geometrical area. So totally up to you. Select this contour. The dimension is 42 and it's about mid plane. You can see there is nothing extruding over here because the contour is not selected. Now we need to create this connecting part, okay, which will be joining these two cylinders. Okay, so here the part is bit wider and the other part is bit narrower and it has a fillet of 78. So we can create either of these sides. So let's go and create this side. So we can see that these are the hidden lines. This is a fillet. Okay, so I'm not bothering about it right now. The concern is that, okay, which cross section how I am going to create. You can create it on top plane if you prefer this way. Or there is one way that I prefer is selecting a right plane and creating a rectangle of dimension 26 comma this height. This height is 28 plus 7 plus 7, that is 42. 28 plus 14 is 42. So we will select right plane, create sketch, go to center rectangle, put on the height and the width. Finishing the sketch as it is fully defined, extrude it, switch the direction and say up to next. It will be merging with this geometry. It will be forming a single body. So now we are having two different bodies, this one and this one. Great. We are progressing. Now, if you see into the image, this part, okay, it is straight up to here, up to the distance of 34, and then it starts tapering. Here also we are going to ignore these fillets right now. We are focusing on this dimension 19, 26, 34, right? And this will be the extrusion. That means we are going to sketch on top plane. The extrusion will be of value 26. So go to the top plane, create a new sketch. Okay, I can select this edge and say convert entities. We can mirror this sketch or can actually create one. You can just use this line, but what I do is actually I make it construction geometry and I extract this circular edge by using convert entities and trim the extra part. Now we add some constraints that these two lines are equal in length to each other. This is horizontal, great. We'll add this distance 34. We'll mention the length of this line 19. Your sketch will be fully defined. Be sure that it is a closed loop. Extrude it by an height of 26 about mid plane. As I said, there is no specific way. You can consider different ways on this, but this is the way I like to create the part. So adding fillets, constant size fillet, multiple radius fillet. First value will be 150 units on this edge and this edge. Then we'll select this edge and edit the radius to 78. Same 78 will go over here. Then select this one and add in the radius value of 35. Same 35 will go over here. Let's just make sure that all of the values we have fed in are correct. Yes, they are all correct. 78, 35 and 150 units. Once this is done, we can say OK on the fillet command. Now it's time to create this fin over here. Okay, so we can create the fin on this face. So select this face and start sketching on it. And we'll be extruding that fin to a value of 7 units downwards. So seeing the shape, you can say that we can create this shape up till here. We can get the mirror image of it over here. We can connect that with this arc. As the dimension suggests, the radius of this arc is 72. It will be repeating on all of these edges. The radius of this arc is 13 units and it will be repeating on all of these edges. The holes will be creating the holes separately, so we will not mention anything about that in this sketch. And when we extrude, if I just create this profile like this and close the loop over here, it will extrude and fill this region. We don't want to fill this region, so we will be extracting one of this cylindrical edge into our sketch by using convert entities so that this face remains hollow. So let's start. Start with the arc command, 3-point arc, and be sure you click on this straight edge, not on the arc edge. And start creating this arc. Add the constraints, add the dimension, you must be patient while doing this. First select this edge and say convert entities. We got this circle, so when we extrude it, this part will remain hollow. So add the constraints. First geometrical constraints, then dimensional constraints. As you can see, the distance between this center and here is 26, then this center and this center is 17. This is 39 and 15 from this center. Fifteen, 39, 15. We can add tangential constraint between these two edges. Close the loop. We'll be requiring this line. We can make it right now. We create a center line. First select these edges. The mirror entities. About. Be sure the copy option is checked. Select this line in mirror about and say OK. Add tangency. Give equal relation. So instead of creating the sketch one by one and then adding the symmetricity constraint, use mirror command to do that for us. To finish the sketch and say extrude, flip the direction and the value will be 7 units. Operation will be blind. Now we are going to create this slot cut over here. So select this face and say create sketch. Create a straight slot. The dimensions for the slots are length is 130, radius of this arc is 5, that means width is 10, and this center point of this arc is situated at a distance of 30 from the center of this circle. Then we are going to cut it such a way that out of 42, 5 units is left, okay, when we cut it from both the sides. Okay, so that means out of 21, 2.5 should be left. That is what our focus should be. So you just select this circle, this circular edge, and say that distance is 30, which is 130, radius is 5. Right, so we have created the sketch on this face. Be sure you don't create it on this face. Sometimes you might make such mistake. Now we are going to use extruded cut to cut this feature. Okay. So as you can see, 42 minus 5 is 37 divided by 2. 18.5 is the depth of the cut we are going to use. Now selecting this boss extrude and cut extrude 1, we are going to use mirror command, and in mirror plane we are going to select top plane. Be sure you have selected features to mirror and not bodies. Click OK. There we are. Once this is done, I will create a sketch on this face. Let's go and place some points. So they are snapping on the center of this arc. I don't have to go and add any constraint manually on this. And notice that sketch is fully constrained, those points appear black. Now going into the hole command, we'll describe the features of the hole. Hole is of dimension 10 units diameter and it's typical on all of these locations. So a simple hole would do, drill size of 10 units. So custom sizing, I will put this off. I keep the hole through all, and while going into the positioning, instead of clicking on 3D sketch, we will select this face. Then we can place the holes on each of the points. You can do it this way, or you can place one hole and then you can sketch pattern it. Once done, I will hide the sketch of these points. Hit Ctrl 7 for a default isometric view. If you go back to the assembly, in bill of material, they have not mentioned the material for this part. But just for this example purpose, we will add a material to this part. Let's say I go to materials, right click and say edit material. And maybe we'll choose like cast carbon steel, maybe. Let's see. Apply, and After applying the material, we'll go to this custom properties, file properties into the custom property, and we'll add two informations over here. If there is nothing coming over here in your list, you can literally write down over here. There's no problem with that. As I have the list, I will be selecting material. Then from here in the value, you can call the property. So this list will always be there with you. If you have applied the material, it will show what material it is applied with. Similarly, for weight, you call for the property called mass. You can call any of the property, you can name it and define which type of property it is. You can call that property. If you fed in the value, it will be visible over here and you can extract it in your bill of material. So once this is done, say OK, save this part now. Let's have call this file as assembly 3. Name this part as master rod. It is a .part file. Click save and we are done. If you find any questions regarding this modeling, you can ask me in the comment section. Next video, we will be modeling articulated rod of this assembly.